are going to deal with hydrostatic forces. I think it's going to feel like a physics class, or at least it is for me. So what is a hydrostatic force? Well, this is the general formula for it. It's nice and cryptic. The hydrostatic force, the total force, is the integral from A to B, delta, a typical width multiplied by the depth at that width, dx. And these are nice and cryptic because these change depending on the shape. And delta, however, is a fixed number. It's basically the density of the liquid. And delta will be 62.5 when the units are in feet. So if you're doing a rectangle or a triangle and it's under the water and it's 5 feet wide and 2 feet tall, this is going to be the value that you use for delta. And when it goes metric on you, you're going to use 9,000. Did I put too many zeros in there? I did. It's going to be 9,800. And 9.8 for gravity and 1,000's to do with a cubic meter of water weighs 1,000 kilograms. So far so good. Now I'm going to do a kind of refresher one just to get into the swing of things. So I'm going to do another rectangle underwater. And once I've done that, we're then going to look at what are called similar triangles, and I'll show you how you use them. And once we've got that similar triangle thing out of the way, I'm then going to do triangles underwater. And depends if we have time, I'll then talk about how to do half circles and things underwater. So it's, oh, I know, Emma, it's going to be rectangles, pretty easy, triangles, and bits of circles, yeah, right? So that's going to be the 3 kinds. So let's have a story. You got some water. You've got a rectangular plate. And this rectangular plate, you'll be told its dimensions. Let's just say, for argument's sake, that from there to there, 6 feet. And from there to there, it's 3 feet. And that it's 2 feet underwater. We're being asked to find the total hydrostatic force on that plate, right? The entire plate. So you really need a picture for these questions. I can't see how you can do it without a picture. Even a simple one like this is worth it. You randomly do a horizontal, so it's always going to be horizontal strip. And the distance from the end to the end is what we call the width. So that guy there is the width. You then, in this particular question, although this varies a little bit, you then have a distance from the surface to that guy. And the distance from there to there is what we'll call the depth. Now, the only thing we don't know really as a number is that, and I'm going to call that x. So in this question, the depth is just x. The width, well, the width is distance from there to there. And in a rectangle, it's the same number, right? It's always 6 in this case. So in this case, the width is 6. But in later questions, you imagine a triangle, for instance, won't that width change according to the depth? You imagine a triangle, at the top it's quite a small width, but at the bottom it's quite a long width, right? Now, once you know those two guys, you're pretty much good to go. The hydrostatic force then will be the integral from a guy called A to B of a delta, a width, a depth, and we're using x. Oh, by the way, in some videos that you might watch or some other textbooks, they sometimes call this distance y instead of x. You know, it's just a placeholder for something you don't know. I suspect the reason they call it y instead of x is, isn't it like vertical, and vertical are y's and x's are horizontal? If you need a reason. But if you look at a question like that online, if you just turn all the y's into x's, it'll be the same question, right? It'll look just like this. So back to this fella. It's going to be, well, A to B is from the start of the shape to the finish of the shape. And we're talking about the depth. In this case, doesn't the depth start at 2 feet, right? And it finishes at 5 feet. You happy about where the 2 and the 5 came from? The 2 is the beginning depth, right, the A, and B is the finishing depth, right? So you start at 2 feet and the shape finishes 3 feet later, so that's at 5. Delta, I'm going to stick outside. The width here is 6 feet and the depth is X. So I'm going to go delta, power rule. And this guy here is 3 times 5 squared, take away 3 times 2 squared. So that's going to be delta times 75, take away 12. Okay, that's going to be delta times, so what, 63. And then I'm going to turn the delta into a number so I can get my answer. And it's 62.5 times 63. And I get 9339, I should say, 37.5. And there's your answer. Have you noticed that I've just kept this thing as delta until the end? Now, I could have turned it into 62.5 here. And do you know the only effect would be to make it really ugly and messy with numbers? So if you keep it as a placeholder, and then once you've sorted out this number, you can then turn it into 9,800 or 62.5, you know, whatever it is, if it was metric or if it's feet. And you're done. Are we comfortable about rectangles? So any rectangle underwater is pretty much going to look like this guy, right?
Could you factor out the width too?
You could have in this case.
Okay.
Typically, the width is going to have x's in it, so it won't happen. But in this case, you could have. Okay, I'm going to call that good then. If there are any questions, this is your chance. Okay. So next, we're going to do a skill building thing. Because we're going to need this. We're going to need this a lot, because in pretty much every question, we're going to use similar triangles. So this is what a similar triangle looks like. You have 2 triangles, same shape, just one's bigger than the other. When that happens, they are called similar triangles. And there is a property that similar triangles have, and it's phrased something like corresponding sides are in equal ratio. So you can imagine this side A corresponds to this D. In other words, on the little guy and the big guy, aren't they the same side? And vertical B and A, and this slopey green one, C and F. So according to similar triangles, A matches D, so A divided by D will be the same number as B divided by E, which will be the same number as C divided by F. That means that we can use this to find a missing E or a D or an F, as long as we're given at least one side in the second triangle. So let's pretend that this guy was 4, this guy was 6, this guy was 7. And we have a little baby version of it over here. And if it doesn't look like it, can you pretend that it's the same shape? Because I'm really bad at drawing these things. And we'll have this guy as 2. And I'll call this guy X. If I was only interested in what size is X, right? How long is X? And I know because I'm being told that they're similar, then you take 4 divided by 2, and it will be 6 divided by X. Do you see that what you get is a little equation, 2 fractions equal to each other? We call it ratios, but they're fractions as well. Now, if you cross multiply, and then you divide, you now have that guy. Now, very often, the 2 triangles, the similar triangles, are not separated. Very often, you'll feel or you'll see that they are right angles. Right angles are very common in these questions. So there's a right angle. And there's a little line up here, and that's a right angle. Now, this distance here is going to be 4, and this distance here is going to be 10. And this distance from here to here is going to be 8. And this distance from here to here is going to be, I don't know. Now, this picture does have 2 similar triangles. You just got to visualize them being separated and drawn next to each other. So if you wanted to know what that would look like, can you imagine you've got the big one, 10 by 8, and then the little baby one, 4 by X. Can you see the similar triangles now that I've separated them out? So that would be the baby triangle, right? The top piece, X by 4. And then if you rub that line out, can you see the big triangle now? 8 by 10. So 8 over X is equal to 10 over 4. Do you see I can now use similar triangles to find how big X is? A little cross multiply and a divide. Are we cool? Now, still on triangles, let's look at isosceles triangles. And in this isosceles triangle, this side is 10, this side is 10, and this side is 8. And I'm going to draw a line, say about here. And this little triangle at the top, like that. This little triangle here, I've got to kind of emphasize some things here. I would like to know, let's make this 4 from here to here. I would like to know okay. So my little triangle looks like this. And my big triangle looks something like this. Do you see the corresponding sides? So basically, and it doesn't matter who you make first and second, as long as you're consistent. So why don't I do the little guy first? 4 over 10 is equal to X over 8. Cross multiply, oh, by choice of numbers, 3.2 again, right? Last one. Suppose we do an isosceles triangle. And I'd like to find that guy. And I'm going to tell you that from here to here is 14. And vertically, from here to here, it's 7. So it's going to be a little bit harder for us to figure out what the two similar triangles are, because the guy that we know, oops, I have to tell you something else. What color? Green. The pieces that we're told don't quite match very easily. And the reason for that is that you think that the triangle is going to be a big guy and a little guy, but actually it's a big right angle triangle and a little small right angle triangle. And the small one is here. And it's X and 3. And the big one, this fella here, is 7. What's this distance? Because it ain't 14.
7.
Do you see that we now have the matchup? So essentially, it might look like an isosceles triangle, but if you take an isosceles triangle and you split it right down the middle, don't you just end up with right angle triangles? So this is actually a right angle triangle. So what would I get? I would get 7 over 3 is equal to 7 over x. So that's a very bad question. Number-wise, it ends up being 3. Okay, so this is just like a taster of how you can use similar triangles to find missing lengths on another triangle. So here is an example of that getting used. This is going to be like question 12. There's the surface. There is a right angle triangular plate, and it's put, let's see how far under the surface. We'll make it 2 feet. And this plate happens to have this number here is 6 feet, and this distance along here is 9 feet. Now, since it is in feet, delta is going to be 62.5, right? Right, everything we need to know is here, but we need to create, if I can get this guy out of the way, don't we basically need to create a little strip so that we can get width and depth, right? And this is where the first change is going to happen. I'm going to randomly choose a place to put my strip. And that's going to be the width. I'll just call it W because I don't want to have to write the word width, but it is the width. And the distance from here to here is the depth. I'll just call it, I know, depth, right? So if I can find out what the depth is, and what the width is, then I should be able to use this fella to get my answer. Well, it's not going to be anywhere as simple as a rectangle. First thing I am going to do here is I am going to call this distance from here to here, I'm going to call that x. Which means that isn't the depth the distance from the surface to this strip. Now, in terms of x, what is the distance from here to here?
2 plus x.
Agreed? 2 feet plus x, which I'm just going to call x plus 2 because I want to. Are you happy about the depth? Now, the hard guy is the width. I need to know what the width is in terms of x, right? So what I'm going to do is similar triangles. So in the similar triangle world, the big triangle is 9 by 6. And the baby triangle is W. Oh, wait a minute. Isn't it this side that I need? So this side, this distance, is not x. What is this distance in terms of x? You know that's 6. You know this is x. So what's this distance in terms of x?
6 minus
6
x.
minus x.
Yeah. Now, 6 minus x, right? Do you see how it's kind of nitpicky now? It's not just, oh, you see an x, you stick in an x, right? It's a little bit more messy than that. But I do have everything that I need. And if I thought this darn thing through, I would have put that in a different page. So I'm going to do it in a different page now because it's going to take more room than I've given myself here. So nice big version of the same story. We have a 9 by 6. We have a width by 6 minus x. And these are similar triangles, right? Which means you can take 9 over w and 6 over 6 take away x. And our job is to find out what w is, right? What the width is. So we're going to solve this equation for w. So if you cross multiply, 6 times w gets you 6w, and that's going to be 9 lots of 6 take away x. That makes it 9 6s 54, take away 9x. If you divide everybody by 6, you get 9, and 9 6 is 3 over 2. Are you comfortable about how I found out what w is by using the similar triangles? Which means that we now have 9 take away 3 over 2x. Go on, go on, go on, Mummy. That was our dog paying her visit. So I'm going to stick the delta there. The width is 9 take away 3 upon 2x. The depth is x add 2, and it's a dx. So the only thing that is left is to figure out what the value of x is going to be, because this is dx. So in this story, where does x start and where does x finish? Right. If you're at the top of this shape, what value of x do you use there?
2.
Is x 2 there? If x is the distance from here,
0.
yeah. And what's it going to finish at when it gets down here? Now, if you're wondering what the heck's going on here, why it's not, 2 to 8, can you see this guy here? When you plug in x equals 0, don't you get a depth of 2? When you plug in the other one, you get a depth of 8. So do you see how x add 2 has kind of taken care of that depth thing? So the top of the thing will have a depth of 2, and you get that because x is 0. And the bottom of the thing will have a depth of 8, and you get that by making x equal 6. So this time, the A to B is representing the values of x from the start to the finish of the shape. Now, in this case, it's going to be delta. Oops, a bit too quick from one good here. The integral from 0 to 6. Foil this darn thing out. What am I going to get? Negative 3 upon 2x squared. That guy times that guy is negative 3x. Add that, so it's plus 6x. And add 18. Hope that's right. Now we get a delta. Add 1 to the power and divide by 3. Add 1 to the power, divide by 2. Do an 18x. Do an x equals 0 to x equals 6. Can I just dot this, because it's just going to be really ugly and big, but it is doable, isn't it? Just messy. So can you imagine plugging 6 in here and then taking away 0, and then at the end, times 62.5. Any questions about that?
How come we do the start and end points of the integral differently?
It's because the x is representing the start and the finish points here are in terms of x. Now, in the first question, wasn't x the depth? So the start and finish point and the depth were the same thing. Now the start and finish point are the values of x, and the x is the top of the shape to the bottom of the shape. So it's going to be 0 to some other number. If I decided to call this distance x, this equation would change. Essentially, this thing here would be an x, and these numbers here would change. But what would be worse is that this thing here would be really, really ugly looking because the numbers wouldn't be clean anymore. So to make this nice, we had to make this a little bit messier. So you're gonna, what you gain one side, you're gonna lose on the other. So the key here is dx. It's saying what are the range of x's, and in this shape, x starts at 0 because x is the distance from the top to here, right? So x starts at 0 and it finishes at 6 in this case. Okay, let's try another one. Let's do another triangle. Yeah. Here's the water line. Let's do the triangle this way around. Right, that shouldn't cause too much trouble, you think? Let's do that 6 and 4. And let's have the triangle 1, and we'll make everything meters. So since everything is meters, this is going to be 9,800. Right, so I need to figure out a depth and a width, and then I can put the whole thing together. Guess I've decided to switch the order for no reason I can think of. It's a little right angle triangle again. randomly choose a point and call it W, right? That's width. At the top of the shape to here, I'm going to call that distance X. So what's the depth going to be in terms of X? And the depth is from the surface to the strip W. So what's this distance here, the depth, in terms of X?
1 plus X.
Okay. Are we comfortable with that, guy? It's kind of what happened the last time. And jumping ahead a little bit, because I'm calling X the distance from here to here, what will be the limits A and B? So what's the value of X at the top of the shape going to be?
0.
And what's it going to be at the finish? At the bottom.
6.
Right. Do you see how that works, right? Why it's 0 to 6 now. Okay. Now back to our picture. The hardest part is almost always going to be to calculate the width, right? So I have got a little baby triangle, and it's X and W, and I have got a big triangle, and it's 6 by 4. And the good news is I don't need to do anything. Don't I actually have everything in place? I didn't need to tweak it like we did the last one. X matches 6, right? W matches 4. So X over 6 is W over 4. 6W is 4X. W then is 2/3 X. Actually, that one went a lot smoother, didn't it? A little bit less work. So it's going to be delta 1 plus X, 2/3 X. The integral from 0 to 6 of 2/3 X plus 2/3 X squared. Add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. Evaluate at 0 and at 6. I think I'll try and take this one to the end. 6, 6, 36, 30, 36 is 12. Sick God in Himmel, I shouldn't have done that, should I? Too late now. 6 cubed times 2 divided by 9 is 48. No, could have been a lot worse. Take away zeros. So what do I get? I get 60 delta, 60, 9,800s. So 60 times 9,800. And that gets me 588,000. A massive, over 500,000. Massively big number. Are we good? Any questions? You know, you are allowed to ask. You feel comfortable with the process so far? Okay. If we are, we shall move on. Let's do an isosceles triangle. So is like 13. Here's the surface. We are doing metric. So that's going to be my delta. It's on the surface. That's going to be interesting. And what do we know about this triangle? Its base is 4. And its height is 5. Ready to get started? Pick a place to do your strip. Call it W. The distance from here to here is going to be your depth. What number, that's probably a bad way of phrasing this. How will I measure X?
Would you subtract 5?
Interesting. I can imagine having to do that in some questions, but I wouldn't. Do you know what I would do? Can I just make that X? In other words, the depth can be X. No, seems reasonable. Why? Don't I measure X from the top of the shape to the strip? And if the top of the shape is touching the surface, won't that be the same thing as X? Right, this is for triangles. Right? X is going to be from the top of the shape to where the strip is. So in this case, we already have the depth, which is X. We need to get the width, which we haven't got yet. And once we have that, we can then put the package together. I'll pull out the delta. Okay, in this question, in this situation, what are the values of A and B? So what will the value of X be at the top and then at the bottom?
0
0
and
and
5.
Right, do you see now it's back to 0 to another number and it's the same as the depth? It depends. Now, if I took this triangle and slid it, you know, baby version of it, and slid it down here, and I made that distance there 3 meters, wouldn't the depth now change to X plus 3? Right, because we would measure X from here to the strip. Right, so each question's got to be treated on its own merits. Right, let's go back to figuring out what this width is. Because this fella seems to be missing something. If I draw my little baby one, and next door to it, I draw my big one, I know this distance is X, and I know this distance is W. And on my big one, I know this distance is 5, and this distance is 4. Oh, someone's dog's not happy, and it's not my dog for a change. Okay. Can we do similar triangles using these numbers? So can I say x over 5 is w over 4? Do you think I should be allowed to do that?
Aren't they ratios? So
Yeah, they're still
couldn't you?
ratios. So yes is the answer. So x over 5 is w over 4, which makes 5w 4x, which makes w 4/5 x. So what we've got now is a 4/5 x times an x, a dx. It's the integral from 0 to 5 of 4/5 x squared. Add 1 to the power, divide by the new power, evaluated at 0 and at 5. So what's that going to be? 4/15 times 5 cubed, take away nothing. Okay, I'll do that in my calculator. 5 cubes is 125. Multiply that by 4. I get 500. Divided by 15. It's 9,800, which is delta, multiplied by that guy. And it's not going to be pretty. It's 326,666.7 roughly. That's kind of all we've got time for today. For the last few moments, say hi to get attendance. Okay, quite a few people missing today. I'm not quite sure what the problem is. I wouldn't want to miss today. I think today is quite different from a typical day, isn't it? Stuff that you haven't maybe seen ever, or at least in a long time. Okay, well, when I get you tomorrow, we will definitely be finishing these off, because tomorrow we have the dreaded bits of circles. And they are really messy. But that's another day. Well, I'm going to hang about for a few minutes. Emma, you are not allowed to screw up your face tomorrow when we do circles. I'm telling you that right now. Okay?
Okay.
Okay. At least I've warned you enough that you shouldn't be surprised. I'm not sure about you, Douglas. You're allowed to screw up your face because you haven't done it yet. So when we do it tomorrow, you're allowed to go, oh, I don't know about that. Right. Okay, bye-bye, guys. I shall see you tomorrow. As I say, I'm hanging about if anybody's got a homework question.
Professor, did you print out or post the work for one of the problems for 8.2?
Yes, it's should be in Canvas. I did it this morning. Can you see it?
Oh, let me check.
It should say something like question 9 homework, something century mass, some name like that.
Is it in the lecture notes?
It's in the main page of Canvas. So on your front page of Canvas. Let me go in.
Solution to question 9 center mass.
That's the one, right?
Okay.
So you click on that, there's a video, and I just went over the solution.
Oh, great. Thank you.
Okay.
What I was hoping if we could go over the other problem.
Sure.
Not it was the sine and cosine one.
Right. Have you got it handy? Just to remind me.
Yeah. It's 8 sine of 2x and y is equal to 8 cosine of 2x.
And it's got an interval like
0
6.
to pi over 8.
Right, that seems reasonable. Okay, so in this case here, we're trying to find the center of mass, right?
Yep.
Yep, so I'll draw a picture of what that guy looks like. If you draw the 8 cosine 2x, it comes down like this.
Oh, I can't see your screen.
Oh, then you reminded me. Can you see it now?
Yep.
Right, so it comes down like that. That's what y equals 8 cosine of 2x looks like. And then I'll do a different color. 8 sine 2x kind of comes up like this. Right. And was there anything else there? Because I think there was a y equals 0, if I recollect. Was that, or was that a different question?
Yeah. Yeah, I forgot to mention that, sorry.
It is a y
It's-
equals 0? Or what?
yeah, it's x is equal to 0 and x is equal to pi over 8.
Yeah, but is there anything to do with y's? Nope.
No.
Okay, so that's, I'm betting some money here and I may not be right, but even if the picture's wrong, it won't change what I'm doing. I'm pretty sure that that's pi upon 8 then. I guess I
Yeah.
can find out. Right. So in this case here, we are going to have to find a first, which is the integral from 0 to pi upon 8. And one of the good things about drawing a picture is, can you now see that the f of x is the cosine, and that the lower one of the two, the sine, is the g of x?
Yeah.
Right, and that's kind of helpful because I make sure that I get this the right way around. So I'm going to be looking at 8 cosine of 2x, subtract 8 sine of 2x, dx. You comfortable with that?
Yep.
I could pull out the 8. I'm just going to be lazy and not bother because I know something's going to happen in a minute. If you integrate the cosine of 2x, you get the sine of 2x. What else do you get?
4.
Agreed. Because it's 8 times a half. And if you do a sine, don't you get a negative cosine? But
So it's
a negative
positive.
sign gives you a plus and also a 4. So I'm assuming that that's not a big deal. You're quite comfortable with that, right? So if you do 4 times the sine of 2 pi upon 8 is pi upon 4, and you add to it 4 times the cosine, and that's also pi upon 4, right? 2 lots of pi upon 8 gives you pi upon 4. The exact value of that guy is root 2 over 2. The exact value of that guy is root 2 over 2. That gets you 2 root 2. So does that guy. So it looks like we got 4 root 2. Does that look good?
Yeah.
Okay. Let's get x bar. 1 over a, the integral from 0 to pi upon 8, basically a to b, and then won't it be x times f of x take away g of x dx.
Yeah.
And 1 over that guy is just messy, is that. And it's going to be an integral from 0 to pi upon 8. Since this fella is a cosine and this fella is a sine, what you end up with is x 8 cosine to x minus 8x sine of 2x dx. Are you comfortable? I've done kind of 2 steps there, but where the ax cosine and ax sine come from?
Yeah, I saw you distribute the x and
On this guy and this guy.
yeah. Yeah.
Right, so ax, this guy, take away that one. Which means that we now have a bit of an issue. I need to know what this guy is and this guy is. It's probably a good idea to do them separate and subtract them. So let's do the first one. Let's do the 8x cosine of 2x dx. What method am I going to use to solve that integral? What technique?
U sub.
Nope.
Product rule.
What was that word?
Product rule.
Oh, integration by parts.
Oh yeah.
Okay. So make this the f and make this the g. Then according to integration by parts, it's f big G, take away the integral of f dashed big G dx. So that's going to get me, leave that guy alone, 8x. If you integrate the cosine of 2x, you'll get 1/2 times the sine of 2x. Subtract the integral of this guy's derivative, which is 8, and the integral of cosine 2x is 1/2 the sine of 2x, and then you have a dx. So what I now have is 4x the sine of 2x, take away 4 times the sine of 2x dx. Now I'm almost done. This fella here, when you integrate a sine, you get a negative cosine, so that makes it plus, and you also get a half. So if I do it all in one go, that's what you get. So the integral of this becomes a positive 2 cosine 2x. So we're comfortable with those steps all done at once.
Yeah.
Right, and this whole package then can now be evaluated at 0 and at pi upon 8. So it's going to be 4 times pi upon 8 times the sine of a quarter pi, because that's what you get when you double pi upon 8, plus 2 lots of the cosine of pi upon 4. Subtract. You plug in 0 here, that goes away. If you plug in 0 here, you get 2 lots of the cosine of 0, which is 2 times 1. And because I'm running short of room, I'll just write the answer. Now, this guy becomes pi over 2 times root 2 over 2, plus 2 times root 2 over 2, take away 2. And what do I get out of that? I get root 2 upon 4 pi plus a root 2, take away a 2. Are we comfortable with that? So over here then, 1 over 4 root 2 times root 2 over 4 pi plus a root 2, take away a 2. And no matter what you do, that's ugly, so I might as well just leave it like that. I don't think if I distributed this, it would be much better. Maybe I'll try it. I'll change my mind. That guy times that guy, they're going to cancel. You get 1/16 pi. That guy times that guy, they're going to cancel. You're going to get a quarter. And that times that is going to be eventually that. Okay, I guess that's slightly nicer. I'm not saying it's a big improvement really, but that's X bar.
Mhm. Okay.
And I have just forgotten something. That's not X bar.
Yeah, I thought there was another half.
There's another guy,
Yeah.
which I'll put here.
Yeah.
I've got a big feeling that it's going to be very similar to this, and we might get some cancelling. So it might end up being nicer.
Oh, can you? Sorry, I just want to. Could I see that? So, yeah. So right now, so what we just did is we just found the first half section,
Yeah.
and then now we have to find the other half.
And I'm going to find it, and it's going to squeeze it in here and subtract them, and then that will be my X bar.
Oh, okay. Yeah.
So that means I have to return back to this fella. I'm just going to get the positive bit because I know I'm going to subtract it here, so it's taken care of. So I'm going to find the integral from 0 to pi 0.8 of 8x, the sine of 2x dx. And it's almost, but not quite, exactly the same as this one. If you notice the difference is sine instead of cosine.
Yeah.
So it's still going to be integration by parts. Only this is going to be f, and this is going to be g. So what we're going to now get is, leave that guy alone, 8x. If you integrate this guy, you get a negative 1/2 cosine of 2x. You happy about if you integrate a sine, you get a negative cosine, and the 2 gets me that half. Right. Subtract the integral of f dashed, which is 8, times the integral guy, same fella, dx. This becomes negative 4x cosine of 2x. These two negatives cancel out and I get a plus, and they multiply together, and it looks like I get positive 4 cosine of 2x's. And this gives me, well, if you integrate this, you get a positive sine of 2x with a half, so you get plus 2 the sine of x, sine of 2x, which is now going to be evaluated at 0 and at pi over 8. So it's negative 4 pi over 8 times the cosine of pi over 4. Add 2 lots of that, so 2 times the sine of pi over 4. Take away, if you plug in 0, that's 0. If you plug in 0, that's 1. Times 0, oh, times a whole load of zeros. That's nice. So I get negative pi over 2 times root 2 over 2 plus 2 times root 2 over 2. And that gets me negative root 2 over 4 pi plus a root 2. And I'm going to destroy this line. That way I can just put in here these two guys. So negative root 2 over 4 pi plus a root 2. So that's going to be this fella. That guy, take away that guy. Let's see what you get. You get this fella, add a square root, take away 2. Take away a negative is add. Take away a root 2. So it's this fella. That guy and that guy can be added together, and so you get a half of them. That guy and that guy kill each other off. Take away 2. If you multiply this fella by this fella, the root 2's cancel. and you end up with 1/8 pi. And if you multiply this and this together, the 2's cancel, and you end up with that. So unless I did some arithmetic mistake, which is always possible, there is x bar.